Hello students, today we are going to do matter. Very important for you to know what is matter. Anything that occupies space is matter. You might say table, chair, sofa, plant, animal, buildings, yourself, everything is matter. Star, moon, earth, everything is matter. So anything that occupies space is matter. We are going to study how that matter has been, how you classify that matter. You have to study the matter because you are part of it. Matter can be divided into living and non-living. Anything that is living, plants and animals, they are all living, they are included in the living matter. Any plant you take, mango, chiku, banana, lotus, banyan, they all from shrub, small plant to big plant, they are included in living matter. They are living matter. Plants and animals. Humans are also living. We are living, cat, dog, horse, elephant, lion, tiger, all these are living. Jiv, jantu. That is living. Plants and animals. Living can be differentiated into plants and animals because their characters are different. When you say living, they will grow and reproduce to give young ones like themselves. Like a coconut tree will give rise to a coconut plant. Mango tree will give rise to mango plant. So a human being will give rise to human being. Cat will give rise to cat. Dog, dog. So growth and reproduction is the character for the living matter. Living things. Whatever is living give rise to young ones like themselves and they go on for generation to generation. So that is living. Non-living. Non-living you can differentiate into natural. Whatever is already present in nature is natural. Whatever is prepared by us like plastic, that is man-made. So natural and man-made. Wood is natural, but if you make a table out of it, that becomes man-made. So whatever is natural in nature as it is present, soil is natural. But if you make something out of soil like glass you make, then that becomes man-made. So utilizing the natural substance, you make something new, that becomes man-made. You can differentiate matter into man-made and natural. Natural, man-made. Air, water, stars. They are all matter. The air you can just feel. You can feel the air. But still it's matter because it is in gaseous state that you are not able to touch but you are able to feel. And if there is a breeze, the air is in motion, that time you can feel the air. You can feel the sunlight. So here air is a matter. Air, water, stars, every water which we drink, it's liquid but still it's matter. Artificial can be anything which is made by man, plastics, table, chair, whatever is made, LCD, laptops, mobile, anything that a man has made efforts to make, that is man-made, artificial. Now, different kinds of matter occupy space and have definite mass. Every matter has definite mass and they occupy space. So, slowly we'll learn how this composition of that matter has been is done. The smallest part of any matter is atom. Atom is the smallest part. Supposing you take atom of gold or you take atom of iron, the smallest particle will be atom. Just iron, an atom will have all the property of many iron together, gold together, all the chemical, physical properties will be present in that one atom. but that atom is very small. You won't be able to see the microscope that you have in school, compound microscope. You have to see under electron microscope. So what you're understanding here is you have to visualize, but that is the truth. As you cannot, you know you are made up of cell, but you cannot see cell. You have to see the parts of, you can see cell under compound microscope, but parts of the cell you will see under electron microscope. Same way, atom you will be able to see under electron microscope. You cannot control the combination of atom as you want. It will take place as it is present in the nature. So what is an atom? Atom is the smallest possible unit of matter that exhibits all the property of that matter. So if you have taken oxygen, one atom of oxygen will have all the property of the oxygen, but it will be very small, invisible, indivisible particle which you can see under electron microscope. You take iron, gold, copper, oxygen, hydrogen, nitrogen, all these are matter. Even though some are in gaseous form, some are in solid form, but they remain matter. And when you study the atom, you study the atom of oxygen, you study the atom of gold, copper, silver. So it's the smallest possible unit of matter. Smallest unit of matter that exhibit all the properties of matter is atom. Atoms do not have independent existence. You won't be able to see that atoms lying down here, there. No. They are not capable of independent existence. All iron atom will come together to form a lump. All gold will come and form a lump. All oxygen will come together, all nitrogen will come together. So atom is not capable of individual existence. Two or more atoms combine together. Oxygen, some atoms will remain to form atom, but some will combine to form molecule. For example, oxygen will never remain just oxygen. They will combine to form with another oxygen, and in nature you will always find them as O2. They will form a molecule. You will always find them as O2. Nitrogen as N2. Hydrogen as H2. They will combine, they will share the electrons, as you will study later. They will combine in such a manner that O2 will remain, H2 will remain, N2 will remain, because they have combined with each other to form molecule. Sometimes only oxygen will combine. They will form only oxygen. But sometimes hydrogen and oxygen will combine. So what will happen? They will form water. Hydrogen and oxygen, they will combine to form water. So let us stick to the simple example of oxygen and hydrogen. Two or more atoms combine together to form minute particles, which is known as molecule. Then a molecule is the smallest unit. This is the definition of molecule. It's the smallest unit of matter which exhibits all the properties of that kind of matter and is capable of independent existence. Atom is not capable of independent existence. Molecule is capable of having an independent existence. So O will combine to form O2. HO will combine to form H2O. So now all these substances have already been formed. How they were formed? Now this Big Bang theory says, different from form of in the heart of the star, the explosion had taken place to form different substances, and the substance got separated the form of energy. They formed bundle which had energy in them. So which type of energy was there? Different form of energy was there in the bundle. Sound energy, electricity energy, magnetism energy, chemical energy, nuclear energy, solar energy. So this is how we have as a matter have formed from the heart of the star. According to this bang theory, it just exploded and matter was separated in the universe, and that the earth has come to form with this matter which was floating in the universe, and slowly the evolution took place. But let us stick to this. So molecule, it's very simple, but try to understand what is the difference between atom and molecule. And as you go further, it will become very simple. But in your mind, if you are not clear what is atom, what is molecule, and you go further, then you will find chemistry very difficult. This is the basic of chemistry. So try to understand. Atom, very small unit. And atom combining, it becomes molecule. But remember, some atom will be like iron, and they'll become solid. So iron. And how do you get iron from the soil? You have to get the iron, separate the iron. Nothing which you see as ready is ready in nature. You have to extract. With any metal, there's iron, that is copper, bronze, so you have to combine metals. So you have to extract from the soil and make something out of it. So here we are trying to study the atom. One atom is the smallest possible unit of matter that exhibits all the property of matter. They do not have independent existence. So molecule, same atom like oxygen, nitrogen will combine to form a molecule. So O2, N2, because they are two together, always two together. So here similar, oxygen atom, it becomes oxygen molecule. Both are same, but they are very active. Once they combine, they become stable. So O2 is stable, but that becomes the molecule of oxygen. Same way you will see of hydrogen, nitrogen. Here hydrogen and oxygen and hydrogen. Oxygen is enter, from both the side it gets hydrogen, it becomes water molecule. Hydrogen, oxygen, hydrogen. They combine to form water molecule. So center oxygen, both the side hydrogen, and a water molecule is formed with two types of atom. This is a molecule. And they are capable of individual existence. So this, if you see water from Ganga or Niagara Falls or your tap, the chemical formula will remain same. This is universal. So chemistry which you study, it is same throughout the world. So next we see what is molecule. We study further how different states are present. Again, if you see matter, you see as solid, liquid, gas. These three different states, and how the atom or molecule, how the molecules they are present in the different state. Like you see water. Water is this molecule. Two hydrogen and one oxygen. If you take out from the freezer, it is solid. If you heat it, it becomes liquid. And if you heat further, it evaporates to form water vapor. So this is how the change in the state take place. So what happens in between the molecule? What happens in between the atom? You will see now. Now the characteristics of the particle. Particle is what? Atom or the molecule. Both are particle. How they will behave. See, if you see the particle of water, it will behave differently. If you see the particle of gold, they will behave differently. Copper differently. So wood differently. They are either atom or molecule that forms the particle. So characteristics of particles, that is molecule of matter. Molecule of matters. Particles are held together. The molecules, the particles or the atoms, they are always held together. Let us take the example of water, which is a molecule. They are held together. There is a certain attraction which is present between the molecules. So that attraction, force of attraction is known as cohesion. There is a cohesion between the two molecules, two atoms. There is a force of attraction which is known as cohesion. So cohesion is a force of attraction between particles of the same substance. Water, you will find they are together. Why? Because there is a force of attraction, there is cohesion, there is force of attraction which is present, that is cohesion. Cohesion is force of attraction. That force of attraction is known as intermolecular attraction. Molecule में attraction is. So that is what? Intermolecular attraction. Cohesive force, cohesion is present, attraction is present. Water will flow in the direction, water molecule will attract water. So there is a force of attraction which is present between the molecules. Cohesive force, cohesion which is present, intermolecular attraction which is present. Force of attraction between particles of the same substance. Now, force of attraction will be different for different molecules, different substances. Water will have different cohesive force. Gold will have different cohesive force, and it will depend upon the state. Supposing you take water from the freezer, the cohesive force is great because solid will have more cohesive force, more intermolecular attraction. So the space between the molecules will be very less, negligible. But if you put outside under room temperature, it turns liquid. That means intermolecular attraction has reduced and the space has increased. More space is present. Intermolecular attraction reduced when becomes liquid at room temperature. This happens for all the substance. Any substance you take, they can change the state with the change in temperature. Even if iron at room temperature, it is solid, but if you heat, it will become heat at a very high temperature, it will become liquid. More high, it will become gas. All substance can change the state, it depends upon the temperature. So what the temperature does, it increases the space and reduces the intermolecular attraction. Cohesive force is reduced and space is increased. That is how the state changes. Particles of matter always, they have cohesive force. I hope you have understood this cohesion, the force of attraction and change in temperature. So when you heat water, this space increases, attraction decreases, and therefore it becomes vapor. In vapor, the space is more, attraction is very less. So you heat and change the molecular attraction. I hope you have understood this concept of cohesion, that is attraction, the molecule getting attracted, and how the attraction can be reduced and space can be increased. Space and attraction both are inverse, they are opposite. More space, less attraction, more space, less attraction. So I hope you have understood this point. There is attraction between the molecules. Particles of matter always in random motion. If you observe those under electron microscope, you will see that the atoms and the molecules, they are randomly just moving. There's a motion, there's energy inside. There's motion, molecules and atoms moving. So particles of matter always in random motion because they possess kinetic energy. The energy which you possess by movement is known as kinetic energy. I am here standing. I have potential energy because I can move. Once I start moving, it turns into kinetic energy. Same way, atom, they are moving, therefore they have kinetic energy. Increase with increase in temperature. And you increase the temperature, kinetic energy will increase, and vice versa. Means it's reduced, you put the water in freezer, it will become ice. So the energy, as it changes, the state changes. So the particle of matter is always in random motion because they possess kinetic energy. Increase with increase in temperature and vice versa. Particles of matter have space between them. As I explained, the atom molecule, they have certain space in between, which is called interparticular or intermolecular space. You learn to say molecules now, and inter means in between two molecules. The space is known as intermolecular space or gap. Now, due to the random motion of particles, we sometimes bring them close to each other and sometimes keep apart. So, space, it increases, it decreases depending upon the state, the temperature on the substances. Now, this can be explained by a simple experiment. You take a glass of water. Fill half glass of glass with water, and then you put 1 spoon of sugar. Sugar will dissolve in it, but the volume will remain same. So where has the sugar gone? It has dissolved. It has occupied the intermolecular space. So there's no increase in volume. The sugar has dissolved, occupied the intermolecular space. But supposing you go on adding sugar continuously, then at a point it won't take any sugar. Why? Because all the space would be occupied. Here there are intermolecular space which is getting occupied, and that's why there's no increase in volume. This is sugar solution which shows the same volume. Now take a plastic beaker, put some say pebbles, pebbles in that, and then put sugar. Still the volume will remain that. What sugar? Sugar is very small particle. Wherever there is space, they will occupy the space. So the volume remains same. It is not occupying volume, so it remains same. Same way it happens to this sugar water also. Now another experiment which is given in textbook, you put in a beaker glass balls. Glass balls means made up of glass. Put in the beaker, and then put sand. Again, sands being smaller particle will spread, occupy the interspace between the glass balls. Excuse me. So this is how it happens. Here they occupy the intermolecular space. States of matter. States of matter, 3 states, as you know: solid, liquid, gas. And very simple to understand. Solid has got definite shape. It has got, and states are due to the intermolecular force of attraction, intermolecular space. More the attraction, less the space. More the space, less the attraction. And as you can see, solid, it is solid. It has got definite shape. It has got definite volume. If you take anything which is solid and put in a in a beaker, say beaker, you put pencil, eraser, you put in a beaker. Does it change its shape? No, because they have definite shape, definite volume. They do not change with the change in the container. So solid, they have maximum intermolecular attraction, and they have less of space in between. Maximum attraction and less of space in between. Now definite shape, definite volume, intermolecular force of attraction is very strong, intermolecular space is almost negligible for the solid. Properties of solid: rigid, definite volume, retain shape, incompressible, means you cannot compress them, and it has got number of free surfaces. So in solid, if it is very hard solid, you cannot compress, but like soft solid, eraser, if you try to compress, it will get compressed to some extent. Slightly compressible, hard solid, incompressible. So solid state you have understood, liquid state. Now in liquid state, the space little it goes on increasing, but the attraction is again reduced, space increases. Attraction, as you heat the solid ice, it becomes liquid, because space increases, attraction decreases. Here, definite volume, no definite shape. If you take a glass of water, water changes according to the type of glass which you drink water in. So it changes the shape. It has got no definite shape. It changes the shape, but the volume is definite. Volume is definite. Now it has got weaker intermolecular force of attraction. It has got weaker intermolecular force of attraction, whereas intermolecular space is comparatively more. So in comparison to solid, the space is more and attraction is less. I hope you have understood this concept. It's very simple, but if any difficulty, then you might find it difficult to understand. Liquids have greater movement than the solid. They can move. Water can move from Himalayas to Bay of Bengal. Why? Because they have more mobility. Liquids have more mobility. Liquids have greater movement than solid. Properties of liquid: no definite shape, definite volume, can flow from higher level to lower level. From Himalayas to Bay of Bengal it can come, because it can flow from higher levels to lower levels. They have only one free surfaces. Now comes the gaseous state. Gaseous state, again here the distance increases and the intermolecular attraction decreases. Distance increases, intermolecular attraction decreases. They are having less of attraction. No definite shape, no definite volume, flow in any direction, compressed into small area and spread in larger area. They can be compressed also. The gas which you use at home, that is the liquid petroleum gas, is compressed, and when you put on the gas, the compressed air slowly releases the gas and provide for our burning. So they can be compressed and they can spread. Supposing you have collected a gas in one gas jar, and then you put another gas jar over this gas jar, then this gas will spread in the upper gas jar, because they have the mobility, they can move, they can disperse. If somebody puts perfume in at a distance, you can smell that, because that gas can come to our nose and gives us the good smell, because it is in gaseous state. So gaseous state, no definite shape, no definite volume, flows in any direction, compressed in smaller area and spread to a larger area, exerts equal pressure in all direction. If you take a balloon that's full of gas, that exerts equal pressure, because you don't find it takes the shape of the balloon, so you don't find some pressure more on one side and less on side. It exerts equal pressure on all the sides. So it does not have any definite volume and it has no definite shape. There's flow and it moves in any direction, and it has more of intermolecular space, and intermolecular attraction is least. So the distance between molecules is more, it is in gaseous state. So you have seen how it changes. You take the example of water, from solid to liquid to gas. Solid is ice, more of intermolecular attraction, less of space. And then comes the liquid, water. In that, intermolecular space increases and the attraction decreases. And when you heat water with the increase in temperature, the water turns into gas. So here the gas, the distance space between molecule increases and the intermolecular attraction decreases. So this happens in the gas. So this is what happens to the molecule of the matter in different states, and we'll study that further.